Unit 3A, calculating averages from a distribution of individual scores. The ages of 5 seals at the zoo are 3, 21, 3, 9, and 4 years. Calculate 3 averages, mean, median, and mode, for these ages. Calculating the mean. The mean equals the sum of the scores divided by the number of scores, or the sample size. Well, how many scores do we have here? 1, 2, 3, 4, 5. So the sample size is n equals 5. We're going to consider this a sample. The sum of the scores you get by adding all the scores together. That's 40. The abbreviation for that is sigma x, the sum of the x's. These scores are called x's. The sum of the x's is 40. So therefore the mean is given by the sum of the scores divided by the sample size, n. That would be indicated by x bar for a sample mean. If you were talking about a population, on the other hand, the population mean would be mu, and that would be also the sum of the scores, sigma x, but divided by uppercase n, the population size. We're going to be dealing with a sample here, so we'll say the sum of the scores is 40 divided by the sample size 5, so x bar, the sample mean, would be 8. A geometric interpretation for the mean would be the balance point of this picture. In other words, think of this as a beam, and we had these cannonballs on top of this beam. At what point would this beam be balanced? Would the balance point be over here somewhere? No, the left side would be too heavy. So the balance point has to move this way. Would the balance point be over here? No, the right side would go down. So the balance point would have to be somewhere between these 2 points. Actually, where it's going to be is at the mean. 8 would be the balance point. So that's a geometric interpretation of the mean. The deviation of a score is its directed distance from the mean. In this case, the mean is 8. How far is 3 from 8? From 3 to 8. Well, we could count the boxes. 4, 5, 6, 7, 8. So that's 1, 2, 3, 4, 5 boxes. But it's going to be a directed distance. And the algebraic formula for the deviation would be score minus mean, x minus x bar. The score is 3. The mean is 8. 3 minus 8 is negative 5. So we would say the deviation of 3 is negative 5. Or 3 is 5 boxes below the mean. So down here, this would also be a deviation of negative 5. Now what about 4? The deviation of 4. How far is 4 from the mean 8? We could use this algebraic formula and say the deviation of 4 would be 4 minus 8, or negative 4. What about 9? 9 would be one box above the mean. So one box above the mean. Or we could use this formula and say the deviation of 9 is 9 minus the mean, or 1. And finally, how far is 21 from the mean? That would be 21 minus 8, and that's 13. 13 boxes above the mean. Now, if you add all the deviations together, what do you get? Well, if we add the positive ones, 13 and 1, that's positive 14. And if we add the negative ones, negative 5, negative 10, negative 14, positive 14 and negative 14 are opposites. When you add them, you get 0. Well, is this an accident? No. The sum of the deviations is always going to be 0 when you have individual scores. The median is the score in the middle of a sorted distribution, so be careful. A common mistake would be to say, look, 3 is in the middle, so 3 is the median. No. First, you have to sort the distribution. So let's do that. Let me sort them starting with the lowest number, 3, another 3, 4, 9, and 21. We want to find the score in the middle. Well, maybe you can see already that it's 4. However, you could use a formula if you like. You take the sample size and cut it in half. The sample size is 1, 2, 3, 4, 5 scores we have here. Divided by 2 is 2.5. Disregard the fraction. And we'll take 2 scores from the bottom of the distribution and 2 scores from the top of the distribution. If we take those away, what's left is the median, the score in the middle. By the way, if you had, say, an even number of scores, like this, for example, you would do a similar kind of thing. N over 2 would be 4 over 2, which would be 2. Now go down 2 from the top and 2 from the bottom, and you'll notice now with an even number of scores, there is no score in the middle. So what we do in that case is take a number halfway between these 2 scores that are in the middle, 4 and 6. Halfway between 4 and 6 is 5. 5 would be the median. If you don't like that, you could take the mean of the 2 scores in the middle, the mean of 4 and 6. 4 plus 6 divided by 2, that also gives you 10 over 2, or 5, as the median. The mode is the score that's repeated the most. So in this case, 3 is repeated twice, so 3 is the mode. Now you could have a distribution where no score is repeated. In that case, you say we have no mode. Or you could have a distribution where you have more than one mode. 2 is repeated twice and 4 is repeated twice. So in this case, we say 2 and 4 are modes of this particular distribution, and in that case we say this distribution is bimodal. Bimodal means it has 2 modes. So that's one of the reasons why we sometimes don't like to use the mode, because you could have no mode, you could have one mode, you could have many modes. If the outlier 200 is added to the previous distribution, which average is affected most? So we're going to take 200 and add that to the previous distribution. Well, first let's get the mean. The mean would be the sum of the scores, which would be 240, divided by the sample size, which is now 1, 2, 3, 4, 5, 6, and that gives us 40. The median would be the score in the middle. Well, if we have 6 scores now, divided by 2, that gives 3. If we take 3 from the top and 3 from the bottom, there is no middle score, so we want to pick a score halfway between 4 and 9, halfway between these two scores. We could just take the mean of those two scores. 4 plus 9 divided by 2, 13 divided by 2 would be 6.5 would be the median. Now the mode of this distribution, which score is repeated the most? Well, again, 3 is repeated the most. So the mean, 40, the median, 6.5, and the mode is 3. If the outlier 200 is added to the previous distribution, which average is affected most? The mean, x bar, is the sum of the scores divided by the number of scores. The sum of the scores would now be 240. And the number of scores, 1, 2, 3, 4, 5, 6, is increased to 6. So the mean, sample mean, would be 40. To get the median, we need the score in the middle. We could take n and cut it in half. 6 by 2 is 3. Take 3 scores from the top of the distribution and 3 from the bottom. Since n is even, we have no middle score. So what we do is we take the halfway point between these two scores in the middle, 4 and 9. You could do that by getting the mean of those two, add them together and divide by 2. And that's 6.5. That would be the median. The mode is the most frequent score. Well, 3 is repeated the most times. So 3 is the mode. Here are the original averages, and here are the averages with the outlier of 200 added to the distribution. This was our original distribution. For the original distribution, the mean, mode, and median were all in here, all in there. With the outlier added, notice the mode and the median did not change much, whereas the mean did move from 8. The mean was here at 8, and now it's going out here to 40. So the mean score moved the most. Another way to look at that is, without the picture, 40 minus 8 is 32, 6.5 minus 4 is 2.5, and 3 minus 3 is 0. So the mode did not change at all. The median went up by 2.5 points, but the mean was affected most. It went up by the most. We say that the mean was pulled towards the outlier. So outliers pull the means toward themselves, and the mean is the average that was affected most by the inclusion of an outlier. averages may be found on the TI-84. The 84 does not give you the mode, but it does give the mean and median. The first step is to clear the lists in the calculator. So second, memory. Number 4 would be clear all lists. Press enter twice and you should see the word done on the calculator, and that will indicate that the list 1 is cleared, which is the list you're going to put the scores in. Press stat, edit, and you'll see the list, and you'll enter all the scores into L1. Next, you press stat, calculate, and choose one variable statistics. We have only one variable. Then press enter, and on the newer versions of the calculator, you'll have a menu. You'll indicate that the scores are in L1. Frequency list you could leave out, leave it blank, or make it blank if it has something there. Press navigate down to calculate and press enter, and you'll see X bar is 8. That would be the mean, sample mean. And if you navigate down further, you'll see other statistics, including the median of 4. That's the end of Unit 3A. See Unit 3B for averages from frequency distributions.